this takes us to a concept we're going to refer to as degree of operating leverage, which is simply an algebraic or a numeric way of describing the level of operating leverage. So we're going to do this, we're going to calculate this degree of operating leverage as a percentage change in operating income divided by a percentage change in the number of units sold. So the degree of operating leverage, the equation for it is simply given right here. Percentage change in operating income divided by the percentage change in unit volume, or the number of units sold. Now, a caveat here, you can't calculate this at just any level of unit production. This only is applicable, this degree of operating leverage only makes sense when you compute it over a range where the level of production actually generates a profit. In other words, we're in one of those areas, one of those blue areas from the chart. So let's look at, we'll start looking at our leveraged firm, and we want to look at the degree of operating leverage for this firm at a point where both of the firms, the levered firm and the conservative firm, are both profitable. But if we went back to our levered firm, for any given unit level of production here, we had a certain level of profit. So this is the profit level. Our break-even level was at 50,000 units for our levered firm. At 60,000, we actually turned a profit. At 80,000, we had a profit of $36,000, and at 100,000 units, we would have a profit of $60,000. Our conservative firm had a break-even level of units of 30,000 units. Let's look at, we'll make a comparison in terms of the degree of operating leverage between these two firms at the 80,000 unit level. So we're going to be interested in the percentage change in operating profits given a percentage change in units. Our units are going to go from 80,000 to 100. Our profit is going to go from 36,000 to 60,000. For right now, let's concern ourselves just with that, with our levered firm. So here at the top, the levered firm, the degree of operating leverage, calculated as the percentage change in operating income divided by the percent change in unit volume. The operating income went from 24 to 36. From 36 to 60. So go back and make sure that's accurate. Yes, from 36 to 60. So we had an increase of $24,000 in operating income. As a percentage change, we divide that by the original $36,000 in profit at the 80,000 unit level, multiplied by 100 to get our percent up here. We really don't have to go through that process because we're going to divide by 100 as well. But we can leave the 100 in both the numerator and the denominator, and it won't really matter. The percentage change in unit volume, we've gone from 80 to 100. That's a 20,000 unit change divided by 80,000 original units. So our percentage change in unit volume is going to be 25%. The numerator up here, we get 67. The denominator right here, we get 25%. We divide the 67 by the 25, and we get a 2.7 degree of operating leverage. Let's go back for a minute. I'm just going to erase this. We'll erase that. Let's go back for a second and look at our conservative firm. For our conservative firm, the number of units is unchanged, but we're going to earn an extra $8,000. Originally $20,000 at the 80,000 unit level. We had $20,000 of profit. we're going to increase by $8,000 to a profit of $28,000. So for our conservative firm, let's calculate the degree of operating leverage. First of all, the denominator is the same, the percent change in unit volume. That's exactly the same as we had above. The numerator changes. We have an $8,000 increase in operating income. Originally we had $20,000. We divide 8,000 by 20, multiplied by 100, we get 40. Okay, 40% divided by 25% gives us a degree of operating leverage of 1.6, which is what we would expect. The degree of operating leverage for our conservative firm, so less levered, has less fixed costs, the degree of operating leverage is lower. It's only 1.6. Our more levered firm, our firm with more debt, with more fixed costs, has a 2.7 degree of operating leverage. We can also look at this algebraically. We could essentially take the formula that we had on the other page, substitute in some numbers to come up with the percentage change in degree of operating income, percentage change in units. When we manipulate that, we would actually come to this algebraic formula where the degree of operating leverage is equal to Q here is the unit quantity. So the unit quantity is both the numerator and the denominator. Then our contribution margin is our price minus our variable cost, which shows up in both places, minus the fixed cost. So that's the little formula for degree of operating leverage using an algebraic formula. We have to know the number of units at which we're looking at the analysis, and the contribution margin and the fixed costs. Let's look at our levered firm. In this case, our levered firm, we were interested in 80,000 units. The price is $2, price per unit. The variable cost was 80 cents. The fixed costs were $60,000. We're just going to plug each of those into the formula here. Plug all those in. We get the little, we'll get this. We solve through. We'll come down and find the degree of operating leverage again is 2.7. We won't go through the very simple mathematical steps that are required, but that's exactly the same degree of operating leverage that we found a moment before back here, our 2.7 right there. Now let's note, before we finish up the discussion of the degree of operating leverage, that there are certainly some limitations with this. Notice that we assume that as the number of units changed, so this is a limitation of the break-even analysis to calculating degree of operating leverage. In some cases, as we change the number of units, we're also changing the revenue per unit. So, as you probably are aware, when a grocery store wants to sell more items, they reduce the price. Well, the price per unit has changed in that circumstance. That's not an assumption that we made in our assumptions. We assumed that the number of units would increase without the price was going to be constant over every level of units sold. Likewise, if we change the level of production, we might have cost overruns. The costs might not be perfectly linear with the number of units, which we have assumed. Remember, the slope of our line was a linear slope, the rise over the run. Well, we may not have that situation in the real world. That really, to some extent, brings in the whole issue of sort of semi-variable costs, which previously we had assumed away, but we know in the real world those really exist. So if we allow for those nonlinearities, the break-even analysis might look a little more complicated. We might have, essentially, we don't have nice straight lines everywhere. And so there will be some level of production at a very high level perhaps, and this is just conjecture, but at a very high level we might see that the costs due to overruns start to cause the cost per unit to rise more rapidly than we would have in a linear function, and we might, as we're selling more units, we might have to lower the price so our revenue becomes weaker at this level. So it's conceivable that we could end up with more than one break-even point. Having said that, this break-even analysis gives us sort of a reasonable way of approaching these questions, particularly over fairly broad ranges of possible unit production. It's not exactly linear, but it's reasonably linear enough in those ranges that we can do some analysis without being too concerned about the nonlinearity issues. Nevertheless, it's prudent for us to recognize that there are limitations in the real world to the extent to which you can believe in the result that you get when you do this sort of analysis.